So we're just going to run through these three very short, quick questions from page 13, chapter 1 in the book, the David Anderson book. So figure 1.36. So it says, given the plan and elevation of line AB, find the true length of the line and its true angle of inclination to the horizontal plane using auxiliary views. Okay. So the first thing there we have to deal with really is the true length of the line. Okay. So it's the exact same like the other questions we've done. We're going to be setting up another x1, y1, and we're going to be looking at the line. So I'm going to go off my plan view here because in the question they asked for true inclination to the horizontal plane. So it just means that I'll only have to do one extra view and I'll have the information I need. So first of all, set up our x1, y1 parallel to AB in plan. There. So that's our x1, y1. Okay. Now we must bring our points down, A and B, perpendicular to that line. Perpendicular, meaning they meet at a right angle there. And it's always the same thing. We go back two views for our height. So one view, two view. So where I'm going to be getting my distances here is from the XY line to the elevation. Okay, so start with A. So first, so if we want to be accurate, use our compass. Point on the XY line, lead up to point A. Come down and mark it here. Point A found. Extend it up for B. That's point B found. So we have point A here, point B here. We can now join those 2 points. And what we found there, I'll use a black color, is the true length of line AB. Okay? So that's the true length. That's the true length line of AB. Now, the question also asks for this auxiliary angle. So, what angle does the line make with the horizontal plane? Okay. So, in other words, what they mean by that is, at what angle is the line standing up on in relation to the ground? Okay. So, the horizontal plane, we're standing up. What angle is inside here that the line is making with the floor, right? So it's very simple to do this because we've our auxiliary here from the plan. All we have to do is, we can do it 2 different ways. We can extend this line past A until it hits the XY line and find that angle. Or we can go parallel to the XY line, X1, Y1 line, from point A. Like I'm doing there with the dotted line. And whatever angle is in here then, that's our angle of inclination to the horizontal plane. Okay, so we'll just make a little note of that there also. So what I have here, that's our angle of inclination to the HP, horizontal plane. Okay, like I said, you could also extend your AB line down until it hit the X1, Y1 and it'll be the exact same angle. So either way, same thing, right? So that's that question done anyway. Down here, figure 1.37, right? Set up a little differently. So it says, given the plan of a line AB and the elevation of the end of A, the true angle of inclination is to be 30 degrees to the horizontal plane. Draw the elevation, right? So if we want to draw similarities between the 2 questions, okay, this time they've given us the true angle of inclination is 30 degrees. So we're going to have to walk backwards, okay? So we have our plan here. So we're going to be able to set up another x1, y1 here. We're going to bring up point A. We know how high point A is because we have it here in the elevation, so I can mark it. Then I can go at 30 degrees until point B meets it. That will give me then the height for point B, okay? So I'm just working backwards, right? So first things first anyway, I'm going to set up x1, y1 parallel with AB and plan. I'm going to keep it close now because I didn't give myself too much room. So y1, x1. Same as before, same as all the questions we've done in class. AB now get brought down perpendicular to that x1, y1 line. So B gets shot down there, A gets shot down there. Okay. Now, there's two ways you can do this. You can treat A as being on the ground, so marking A here and marking your 30 degrees and drawing it up. Or you can mark your distance up for A here, draw a line parallel to the x1, y1, and then measure your 30 degrees. Something like this I've done here. So I'm going to do it the other way now this time so you can see what I mean. So in other words, I'm going to treat A here as being on the x1, y1 in our auxiliary, right? So I'm going to treat that there as A. So what I'm going to do now is I'm going to get my protractor and I'm going to measure my 30 degrees in here. So I'm going to get my 30 degrees, which is there, and I'm going to drain from point A through that 30 degrees until I hit my B line, okay? I extend this small bit onto the table, which is in grey. That now is my point B here. Yeah, that's my point B here now. So, what am I going to do with that information now? Yeah, the first thing I have to do is, because I treated A as being on the ground in my auxiliary, my measurements are now going to start from A. So all along, I used to be measuring from the x1, y1 line up to their height and elevation. But because I shortened down this distance, I treated A as being on the ground. So A is on the ground here. I now drew a line straight across, and I'm going to be getting the distance from my x1, y1 to my point B in my auxiliary, and marking it from this line here now up to wherever it goes in B here. Getting this distance here, distance set, point to the compass up here, mark it, it's point B found. Now all I have to do to complete the question, join A to B in elevation, and that now is a line AB that has an angle of inclination of 30 degrees to the horizontal plane. So I'm actually going to write that in there now. So angle the horizontal plane equals 30 degrees. I'm going to do a little arrow in here. There we go. Okay, so that's that question done. So I'm flying through these. So the last one here now is figure 1.38. Yeah. So given the elevation of a line CD and the plan one end of the line C, if the true length of the line is to be 80 millimeters, complete the plan. Okay, so we're going to do something very similar here now again this time. Okay, this time we're going to set it up off the auxiliary, so we're going to get an auxiliary plan. Okay, we'll then be able to, so we have point C, it'll be up here somewhere. We'll then be able to mark our 80 with our compass until it hits B and bring it back down through the views then again. Okay, so once again, very first thing I'm going to do, I'm going to set up an x1, y1 parallel to CD. So CD here, set up an x1, y1. So it's x1, y1. Now all my points, my 2 points, C and D, are coming up perpendicular to that x1, y1. So up here and up here. Once again, now I can find my distance for C, but I can't find my distance for D yet, which we'll put in C anyway while we have it, okay? So you go back 2 views. So this is an auxiliary plan. So 1 view, 2 view. So I'm now getting my distances off of my plan. The other ones, I was drawing off a plan. I was getting the distances off of elevation. Okay? So, point to the compass there. Bring it back into C. Just there. Distance on the compass here then. Point on x1, y1. There. So that's C now in the auxiliary plan. But I don't know where D is, right? So I know D is somewhere along this line, okay? And we're stepping back now to this very first question that we done. So the true length of the line we find when we look into this view, okay? It gives me the distance they want the true length to be. So they're after telling me that the true length of the line CD is 80 millimeters. So I'm going to use my knowledge of all this now to kind of work on a few steps backwards. So I have point C, and I know somewhere along this line is D. I know how long it is, it's 80. So what I'm going to do is I'm going to set the compass to 80. I'm going to put the point of the compass on C, and I'm just going to swing it until it crosses my D line. Where the compass crosses that D line, that gives me point D right there, okay? What you can do then, you can join in your C to D, like so. How am I going to finish it in plan? Well, I now have the height. So point to the compass on the x1, y1 line, extend it up to the height of D, which is there. Come down, bring down D, point to the compass on the xy line, swing it. That's now point D, and I can just join in C to D in plan. So that now, that, and this is true length of line C to D. It's equal to 80 millimeters. They told me in the question they wanted it to be 80 millimeters. Okay? So that's our 3 questions there now. Complete. So page 13, chapter 1, dealing with orthographic and auxiliary projections.